So our topic is ergonomics. Let's it's also known as human factors. Let's start with the definition. As per International Ergonomic Association, ergonomics is the scientific discipline concerned with the understanding of interactions among humans and other elements of a system and the profession that applies theory, principles, data, and method to design to optimize human well-being and overall system of performance. Now let's go to etymology. The term ergonomics was also derived from the Greek words which you can see on the screen. It was first entered in the modern lexicon when Polish scientist Wojciech Jaswoki used his word in 1857 article, The Outline of Ergonomic, or that is science of work based on the truth taken from the natural science. Now let's go to importances. Some of this first importance is human factor is employed to fulfill the goals of occupational health and safety and productivity. It is relevant in the design of such things as safe furniture and easy to use interfaces to machine and equipment. Second one is proper ergonomic design is necessary to prevent repetitive strain injuries and other musculoskeletal disorders which can develop over time and can lead to long-term disabilities. Third one, human factors and ergonomics is concerned with the fit between the user, equipment, and environment. It accounts for the user's capabilities and limitation in seeking to ensure that tasks, functions, information, and environment suit that user. Fourth point, to assess the fit between a person and the used technology, human factors specialists or ergonomists consider the job being done and the demands on the user, the equipment used, and the information used, presented and changed. Ergonomic draws on many disciplines in its studies of humans and their environment, including anthropometry, biomechanics, mechanical engineering, industrial engineering, etc. Now let's go to domains of specialization. It has three main fields of specialization: physical ergonomics, cognitive ergonomics, and organizational ergonomics. First one is physical ergonomics. Let's discuss. Physical ergonomics is the science of designing user interaction with the equipment and the workplaces to fit the user. Physical ergonomics is concerned with the human anatomy and some of the anthropometric, physiological, and biomechanical characteristics as they relate to physical activity. Physical ergonomic principles have been widely used in the design of both consumer and industrial products. Physical ergonomics is important in the medical field, particularly to those diagnosed with physiological ailment or disorders such as arthritis or carpal tunnel syndrome. One of the most prevalent type of work-related injuries is musculoskeletal disorder. Work-related musculoskeletal disorder, in other words, in small abbreviation, you can say that WRMDS, results in persistent pain, loss of functional capacity, and work disability. But their initial diagnosis is difficult because they are mainly based on complaints of pain and other symptoms. Now let's go to next, cognitive ergonomics. As the name suggests, cognitive ergonomics is concerned with the mental processes such as perception, memory, reasoning, and motor response as they affect interaction among humans and other elements of a system. Some of the relevant topics under it include mental workload, decision making, skilled performance, human reliability, work stress, and training, as these may relate to human system and human computer interaction design. Let's go to third one, that is organizational ergonomics. Organizational ergonomics is concerned with the optimization of socio-technical systems, including their organizational structures, policies, and processes. Some of the relevant topics under it are communication, crew resource management, work design, work system, design of working times, teamwork, participatory design, etc. Now let's go to history of this field. In ancient societies, the foundation of the science of ergonomics appeared to have laid within the context of the culture of ancient Greece. A good deal of evidence indicates that Greek civilization in 5th century BC used ergonomic principle in the design of their tools, job, jobs, and workplaces. One outstanding example of this can be found in the description Hippocrates gives of how a surgeon's workplace should be designed and how the tools he used should be arranged. The archaeological record also shows that the early Egyptian dynasties made the tools and household equipment that illustrate ergonomic principles. It can be also seen in the diagram. Now in industrial societies. In 19th century, Frederick Winslow Taylor pioneered the scientific management method, which proposed a way to find the optimum method of carrying out a given task. Taylor found that he could, for example, triple the amount of coal that workers were shoveling by incrementally reducing the size and weight of coal shovels until the fastest shoveling rate was reached. Frank and Lillian Gilbert expanded Taylor's method in early 19th to develop the time and motion study. They aimed to improve efficiency by eliminating unnecessary steps and action. By applying this approach, the Gilberts reduced the number of motions in bricklaying from 18 to 4.5, allowing bricklayers to increase their productivity from 120 to 350 bricks per day. However, this approach was rejected by Russian researchers who focused on the well-being of workers. At the First Conference on Scientific Organization of Labor in 1921, Vladimir Bekhterev and Vladimir Nikovich Mashev criticized Taylorism. Bekhterev argued that the ultimate ideal of labor problem is not in it, that is Taylorism, but is in such organization of labor process that would yield a maximum of efficiency coupled with a minimum of health hazards, absence of fatigue, and a guarantee of sound health and all-round personal development of the working people. Massachusetts rejected Frederick Taylor's proposal to turn man into a machine. Now let's go to next topic in aviation. In World War One, the focus shifted onto the aircraft, in particular the design of controls and display and the effect of altitude and environmental factor on the pilot. The war saw the emergence of aeromedical research and need for testing and measurement methods. Studies on driver behavior started gaining momentum during this period as Henry Ford started providing millions of Americans with automobiles. Another major development during this period was performance of aeromedical research. By the end of World War One, two aeronautical designs were established, one at Brooks Air Force Base, Texas, and other at Wright-Patterson Air Force Base outside the Dayton, Ohio. Many tests were conducted to determine which characteristic differentiated the successful pilots from the unsuccessful one. During the early 1930s, Edwin Link developed the first flight simulator. The trend continued and more sophisticated simulators and test equipments were developed. In World War Two marked the development of new complex machines and weaponry, and these made new demands on the operator's cognition. Now the design of equipment had to take into account human limitations and take advantage of human capabilities. The decision-making, attention, situation awareness, and hand-eye coordination of machines operator became a key in the success or failure of a task. It was observed that fully functional aircraft flown by best-trained pilots still crashed. In 1943, Alphonse Japanese, a lieutenant in US Army, showed that this so-called pilot error could be greatly reduced when more logical and differentiable controls placed confusing designs in airplane cockpits. Next topic, information age. The dawn of information age has resulted in the related field of human-computer interaction (HCI). Likewise, the growing demand for and competition among consumer goods and electronics has resulted in more companies and industries including human factors in their product design. Using advanced technologies in human kinetics, human body mapping, movement patterns, and heat zones, companies are able to manufacture purpose-specific garments including full-body suits, jerseys, shorts, shoes, and even underwear. Now in the present day, ergonomic evaluation in virtual environment. In physical ergonomics, digital tools and advanced softwares allow analysis of a workplace. An employee's movements are recorded using a motion capture tool and inputted into an analyzing system to detect hazardous postures and movement. Traditional risk assessment methods are implemented in the software, for example, as in Vive Lab ergonomic assessment software named Rula and NASA UBI. In virtual space, a biomechanical accurate model represents the worker, the body structure, sex, age, and demographic group of mannequin is adjustable to correspond to properties of an employee. The software provides several different evaluations such as reachability test, spaghetti diagram, or visibility analysis. With these tools, ergonomists are able to design a workstation in virtual environment and test it in iteration until the result is satisfactory. Now, human factor organization. One of the Chartered Institute of Ergonomics and Human Factors, established in 1947 in UK. Human Factors and Ergonomic Society was founded in 1957. Association of Canadian Ergonomists Association, ACE, also known as. Formerly it was known as Human Factor Association of Canada. Another one, International Ergonomics Association, AEIA. Practitioners. Human factors practitioners come from a variety of backgrounds, though predominantly they are psychologists and physiologists. Designers. Typically, an ergonomist will have an undergraduate degree in psychology, engineering, design, or health science, and usually a master's degree or doctoral degree in related discipline. Though some practitioners enter the field of human factors from other disciplines, both MSc and PhD degrees in human factor engineering are available from several universities worldwide. Methods to achieve aspects of ergonomics. One of them is iterative design, also known as prototyping. As we also know that before launching a product into the market, the companies which are manufacturing this product, they first release a prototype for the testing, and they are first given to the selected users, and they use this prototype and detect all the flaws in it or how it can be better modified. As per that, the modified product is relaunched. Subject in tandem method. In this, two subjects are asked to work concurrently on a series of tasks while vocalizing their analytical observations. The technique is also known as co-discovery, as participants tend to feed off each other's comment to generate a richer set of observations than is often possible with participants separately. This is observed by the researcher and can be used to discover usability difficulties. This process is usually recorded. Surveys and questionnaire. It is similar to the previous one, but in this, instead of involving two people, a group of people is involved. They also do the same thing as a group, and in this, more and large amount of information is gathered, and the researchers record this information and release the final product. Think aloud protocol, also known as concurrent verbal protocol. This is the process of asking a user to execute a series of tasks or use technology while continuously verbalizing their thoughts so that a researcher can gain insights as to users' analytical process. Can be useful for finding design flaws that do not affect task performance but may have a negative cognitive effect on user. Also useful for utilizing expert to better understanding procedural knowledge of task in question. Less expensive than focus groups but tend to be more specific and subjective. Wizard of Oz experiment. In this, it is comparatively uncommon technique but has been some use in mobile devices. Method analysis. It is similar to the previous ones. In this, task of a worker completes using step-by-step investigation. Each task is broken down into smaller steps until each motion the worker performs is described. Doing so enables you exactly where repetitive or straining task occurs. Time studies. It is purely based on the amount of time taken by the worker to accomplish the job. Uh, Kansei method, it is similar to the previous ones. In this, directly the opinion is taken from the consumers. Weaknesses. Some of these weaknesses are usually it takes more time and resources than other methods. Very high effort in planning, recruiting, and executing compared with other methods. Much longer study periods and therefore requires much goodwilling among participants. Studies are longitudinal in nature, therefore attrition can become a problem. Project members: Sriram Prasad Sahu, Siddhant Ray, Abhishek Subudhi, Ankita Sahu, Sardar Walli Karar, Shakti Swarup Naik. Thank you.